This conference will now be recorded.
All right, so now, first question is, if you want to call add to cart from this line, what do we do?
Initialize the shopping class.
Okay, initialize shopping, very good. Next.
S dot add to cart. And on the left hand side, we have to give a value.
What do we do here?
On the left hand side, we have to assign a value to add to cart.
You need to give a product name.
Okay, Rohil, did you check with Shrestha and Ekta on how to call a reference variable based method?
Yes, I have made a program or a simple calculator. If you want me to show you, I can do that.
So what do we do here?
We have to call like we can give a value because it is passing a value of the product P needs a value over here. So the function needs to have a value in it.
Okay, tell me, what do I write and where?
In the braces, you can write a number.
Do we have to create the product P variable first?
So that's right. Rahul, you tell me, why do you want to pass a number here? Why do you feel you have to pass a number?
Because it has to give the input.
So what is the expected input there?
It's the product P. Sorry, that's object. Oh, my bad. It's a reference.
Yes, be careful when you do this. Okay,
Sorry.
You have to remember that. Like I said, we did this like 100 times, and you guys should remember by now. Okay, so what do I do?
We have to initialize the P, the product.
Very good. Now
in S dot add to cart, we can write PP in it.
that's it. Okay, you don't pass integer. Okay, you cannot pass integer. If it requires product, you have to create a product object and pass it. Okay,
Sorry.
not okay. You don't do product P here as well. Okay, this doesn't make sense either, because this method returns nothing, right? It's void.
True.
If it is void, it is returning nothing. If there is no return, why are you handling return? Okay, so both should not be done. All right, so we'll try two different methods. Okay, one method takes a reference variable, an object, and another a primitive variable. Okay, let's see how they behave. All right, so we have two methods in shopping. Add to cart, which takes an object, and ABC takes a primitive data type, primitive and object. Okay, let's see how they both behave. Okay, so when we create a product object, what will be the content of the of this object? What will it contain?
Reference column.
Yes, PP will contain the reference value. In that reference location, what will you find?
Null value?
You get the
What?
product,
Integer value.
integer value.
You will find a
integer.
variable with value 20. Okay. So when I create an object here and say pp.a, it prints 20. Whatever initialization you did for the a variable. Okay, pp.a gave me 20. Now when I call the add to cart method, I'm passing this pp variable, right? What am I doing in this method when I get that reference? What is the new value of a? Will it be still 20 or 30?
30.
And when I print in this program, what will it print? When I print it here, what will it print?
30 the new value. Okay.
So before and after the same pp variable, okay, we are printing before calling the add to cart method and after calling the add to cart method. In either case, you see different values, but the value was changed in this program or the shopping program.
Shopping program.
Shopping program. Okay. So when you pass a reference variable to another method, any changes you do there, it will be permanently reflected on all the other programs. Okay. As many programs you pass the same variable, they all will see the same updated value. Okay. So reference variables are, they maintain the state, okay, throughout your project. Anywhere you it will reflect in all the programs. Yes. All right. Now let's see the other example, the primitive method example. The I variable value is 20. I print II, okay, or 50. Then I call the ABC method this time, and I pass the II variable, and then I print it again. Okay. In case of product, in case of objects, the product object, right? Before and after values did show the latest values. Okay, whatever changes you did in another program, you could see that here. Before the initial value was 20, and after you send the same pp variable to add to cart method, it got updated to 30, and it did show here. Okay, it did show the latest value that you changed in another program, another method. The same experience we are trying to simulate for the primitive method, primitive parameter method. Okay, this is the object type method. Okay, it takes an object parameter for add to cart, and this method ABC takes primitive variable as the input. Okay, so we had 50 for the II variable. We passed it to ABC, the other method. There we are changing the value to 30. Okay. Now when you come back here, what will it print? 30 or 50?
50.
30.
Should print new value 30.
No.
Still prints 50.
Because initializing
In case of reference variables, whatever changes you do to that variable, it does reflect. Okay, you made changes 30, you come back and print it, it shows you 30. You send 50 primitive, you change it to 30, you come back and it is still 50. Okay, so when you pass a primitive variable to another method and make changes, they don't reflect in the source. This is the source and this is the destination. Okay, in the source program, you pass product variable, an object, and whatever changes you do here, you can see that changes when you come back. The same when you do with a primitive variable, it does not do the same. Okay, it will still remain 50 even though you changed it to 30 here. Okay, let's see why this happens. Okay, okay, this is your main method program. And this is the shopping method that we are calling from the other program. Okay, these are two programs, the main program and the shopping program. Okay, let's see why it behaves differently in case of reference variable and in case of primitive. Okay, these are the lines of code for reference variable call add to cart, and these are the lines of code okay, so these are the lines of code for calling the method that takes primitive. Now pay attention here. Okay, reference variable initialization and primitive variable initialization. We'll see what is the difference. When you initialize reference variable, new product, okay, whenever you see something called new product, as you know, it goes to the memory and creates a new object into the memory. Okay, now this is the blueprint. Product class is the blueprint, and this is your actual creation, actual manufacturing. Okay, just like the house blueprint and the actual building. Okay, that's the same thing. There is a product class and there is a actual version of that product class. Okay, now when you're building something, you look at your blueprint and you go through every little details, right? You find out how bigger the kitchen should be. Okay, should this house have a media room? Should this house have a bedroom? All this information is in the blueprint, in the layout, right? Similarly, when the Java runtime is creating this object, it has to refer to the blueprint and see what goes inside this product, this object. Okay, what is the content inside this object? Okay, to know what is the content in this object, it will refer the blueprint, which is your class. So in a product class, what do we have?
Integer A.
Integer value.
We have
Primitive.
integer a with the value 20, right? This is the layout, this is the blueprint of the product class. If you want to load this program into the memory, okay, here it has to refer the blueprint. Okay, so the Java runtime will check your program and see how can I build a product object into the memory. Okay, so new instructs new is an instruction to build an object in the memory. Okay, just like in an instruction to build, manufacture a car, a house. Okay, the new keyword basically tells that you need to instruct, you need to build an object in the memory. Now the next question is, which object? Which object do I need to build? Okay, there are so many programs. There is shopping, checkout, customer, product. Which object do you want me to build in the memory? So you're clearly saying, I want to build a new object of type product. Okay, so now we know that we have to build an object of type product. So what goes on in the memory is, in a specific location, okay, we are talking about your computer's memory. Okay, that's where all the information is stored. Okay, your RAM. Okay, that's where your information is stored. So what it does, the new operator does, in a specific location in your memory, it will build an object. It will allocate some memory for the product object. Okay, next thing is, what do we add to this object? Okay, what does it consist? Okay, when you're building a house, you need to know how many bedrooms you want, how big a kitchen you want. Okay, where should be the hall facing? All that instruction will be in the blueprint. Okay, that's what this class is. This class serves as a blueprint when it is being constructed in the memory. Okay, so looking at this program, we know that it consists of a variable, integer variable called a, whose value is 20. So here what it does is, it will create a variable a with the value 20. Okay, this is the product object A20. Now that's only the half part, right hand side. When you say new product, this is what it happens. In a specified location, it will create a product object and it will fill with all the information needed. Okay, that's only the right hand side. Now on the left hand side, you have something called product PP. Okay, and that you have equal sign. So when you say equal sign, what does that mean?
Right hand side is equal to left hand side.
You take the right hand side and assign it to the left hand side. Okay, in this case PP. So for PP, the value it gets assigned is 1 to 3. Okay, the value gets assigned is 1 to 3, because in that address you have the product object built. Okay, so when you say PP is a reference variable, what it is referencing to?
1, 2, 3.
It is referencing to an address in the memory. Okay, PP is referencing to a particular address in the memory. All right, so if you guys are not clear, look at the very first 2 sessions that we did. Okay, we went through extensive exercise on how the objects are created, the whole memory concept and everything. Now, the same thing when you say int I equals 50, this is a literal value. It's not a reference, right? It's a literal value. Okay, so just to be clear, I'll write something alphanumeric. ABC 1, 2, 3. Okay, imagine if this is the address. All right. Now, when it comes to integers or any primitive data type, when you say int I equals 50, this is not a reference. Okay, this is a primitive variable. In case of primitive variable, you don't get the memory address or anything. You have literally the value stored in the memory. Okay, so primitive variables literally have values, whereas objects have references, an address reference. Okay, where you'll find all the information you need. In the memory, primitive variables will have direct values, 50, 100. Whereas for object, the reason we call it reference is because it doesn't store 20. like the variable 20, it doesn't store that. What it stores instead is an address location. Okay, in that address location, you will find what you're looking for. That's why this is a reference versus this is literal values. Is that clear on how the objects versus primitive variables are created in the memory? What question do you have? Ask if you want.
So that's why there was no difference. So that's why it was printing 50-50 because it's a literal value that was over here, right?
We'll get to that later. At the moment, just let me know, guys, if you understand how the objects are created in the memory versus how primitive variables are created in the memory. What it printed, we'll get there later. First, understand how these objects are stored, how your programs behaves in the memory. Any questions on this?
No.
This conference will now be recorded.
All right. Shabani, how is this line processed in the memory? Student S equals new student.
S will have a reference point, like let's see, 456, and new student will create a block with a reference, the pointer 45.
Okay. At a reference, a new object is created for student object. Okay, what next?
And then we have to define using the operator.
Okay, what do I do next?
S is the object which is referring to the address 456.
Is that all?
I guess so.
Write this down like 100 times. Creating object, assigning the address to the variable. What is missing? These are just 2 steps. Creating a specific, allotting a memory at a particular address, that is step 1. This is the last step, where you assign the address to the variable S.
Calling the class, like we have ABC.
Mm-hmm.
So here we're gonna call the class.
Use the right term. When you are constructing something, what you need.
Method.
Forget about Java program. If I ask you to build a house, what do you need?
Blueprint.
You need the blueprint. So what's the blueprint in Java program?
Class.
The class. Which class blueprint do you need for this line?
Student.
You should ask, show me the student class. There you go. there is a student class. So how will you construct the student object? Remember, memory is for storing information only. Memory is used for storing information. Hard drive, you download videos and you keep it in your hard drive, don't you? For storing information, you have the memory. So, in this blueprint, where are you storing information? In this blueprint, where are you storing the information?
Student.
Variables.
Yes.
You store information in variables.
Variables. And looking at this program, tell me exactly which are they?
It's a grade and
Grade and integer ID.
Grade and ID, the global variables only, not the parameters. Remember that, not the parameters, not the variables declared inside the method. Okay, this is declared inside the method, not this, not the parameters. Global variables are what store information in the student class. Okay, grade and ID. Now, what are the values for grade and ID?
Zero.
Zero.
Null value.
Zero.
Zero or null?
Zero.
Zero.
So what is step number 1? When you create an object, not a primitive variable, when you create an object variable, what is step number 1?
Create a class.
Create class. Allocate a memory in a specific address. What is next? We just discussed it. What are the step 2?
Save it in a variable. In the class.
Okay, reference ID.
No. Okay, guys, I'm trying to relate this as much as I can. Okay. When you want to build a house, what is the first question you ask? You ask, where do you want to build your house? What is the address? What street? What city? Don't you need the address even before you begin building anything?
Blueprint.
No, just follow me. Okay. When
Yes.
you're building a house, don't you need an address on where, which street, which city you want to build your house? Don't you need the address first?
Yes.
So what are we doing here? We are deciding the address. We are allocating some address for you where you can build your house. What is step number 2?
Blueprint.
You need the blueprint. Now that you know where you want to build the house, that is address 456, you need the blueprint on how to build your house. You know where to build your house. Second step is you need to know how to build your house, isn't it?
Yes.
So in terms of Java program, when you say how to build your house, the first thing comes to your mind is blueprint. Refer blueprint is what you say to build my house. Here, blueprint is equal to the class definition. So here in Java word, you say refer class to build your object. So when you refer class, which is your blueprint, you know what are the variables here, the global variables. It's grade and ID. So what you do, you create grade and ID. Now there are some specification, how big, what value, all that thing. To assign values here, you fall back on the traditional concept. If nothing is declared, integer is 0. If something is declared, default value is 20. So every time you come across this thing, three things happens. Where to construct? Address. How to construct? Blueprint. Okay, and finally, you need to give the address to the owner. Here you go. This is your key. Okay, this is the key to the house. You can use it any way you want. Don't you hand over the keys to the house owner when you're done constructing the house?
Yes, we do.
Yes.
That's what this assignment is. Now that you know the address and you have built the house, the owner, variable s, needs access to the house, don't they? Think about 456, this address as a key. Using this key, the owner can enter this house and make any changes they want. This is the key. 456 is the key or address. Using this key, you can access anything you have in here. Okay, so you can consider this thing as an address, location, or the key. Anyone has key to this home can make changes here. Anyone who has access to this can make changes. If there is another variable s1 who has access to 456, they can gain access to this home. Okay, think about this like a key. Okay, it's a key or a reference key to this address. Very simple. Is that easy enough to remember?
Yes.
Okay, where to construct? Give me the address. Where do you want to construct the house? How to construct? Refer the blueprint. Hand over the key or reference to the owner. Here, basically it's the reference variable. This is true in the real world, and this is how we construct things even in the digital world. Okay, where to construct? Student s equals new student. When you say new student, you're about to create a new object. Okay, where to construct? Some address. Okay, some address. This is where I'm going to construct student object. Where to? How to construct? Okay, now that you have a lot assigned to you, what goes inside this lot? How do you build the house? Where? What do you want? How many bedrooms? How many kitchen? How big the kitchen should be? Okay, do you have a hall? Do you have a media room? That's the blueprint. Similarly, when you say blueprint, you need to refer the class. This is the blueprint. And here it tells us that student has grade and ID. Only the global variables. Method do not retain information. Information is retained by the global variables only. Methods don't store information. What is method used for?
Manage information.
Managing information. It can read the value of grade. It can change the value of grade. That's the purpose of methods. Managing information and storing information. Since memory is all about storing information, you are very much concerned about the variables rather than methods. So since here we have grade and ID, this is the blueprint that we are referring. How to construct student object. We need grade and ID in the student object. This is the blueprint. So looking at the blueprint, step number 2, I will complete the construction of a student object. Now, there are no values associated with grade and ID. So check here. If there is any value associated here, grade is 10, ID nothing. No value meaning?
0.
0.
Grade has 10, ID has 0. Grade has 10, ID has 0. So we are done with where to construct. We are done with how to construct. The last thing is hand over the reference to the owner. Okay. In this case, the whole object creation right hand side was being done for the left hand side S variable. Okay. So finally, S person, the owner of this object, gets access to the key. This is what happens when you create an object. Okay, when you write a line like this is what happens. Is that clear?
Yes.
Yes.
Now the reason you used to get null pointer exception is something like this. If you do not have new student, this was never created, right? If there was no new student, you never constructed anything. So if there is no address, it means this is nothing. This is null. So S equals null. Is it pointing to anything?
No.
No, it's not pointing to anything. Okay, so that's why when you do sys out here on this line and say s dot grade, okay, here when you say s dot grade, what will it print?
Ten.
10.
10.
10.
When you do this line, okay, it went ahead and created an object. Okay, you have the key to the house. Okay, and then when you say s dot grade, using the key s, we go to that address, and inside this house we'll look for something called grade. So we have grade, and the value of grade is 10. So that's why it is printing 10. Now the same thing, if you do like this, okay, you declare the variable and you say sys out s dot grade. This gives you null pointer exception because is s pointing to any address where you can find grade?
No.
No. That's your null pointer exception. Since you never said new student, only when you say new student, that's when you get this. When you say new student, you get this, and hence you can say s, go to this house, grade, get me the value. You don't get any errors when you say new student. But if it is just student s without new student, there is no object created in the memory. S is basically pointing to nothing. Null means nothing. S is referencing to nothing. Since you're not referencing to anything, how can you get the value of grade in the first place? So does object creation make sense? Null pointer exception make sense?
Yes.
You understand how the objects are created in the memory?
Yes.
Okay. All right, so let's get back to our example here. Okay, so that's what we did here. Product PP. Okay, we created that. So when you say new product, first step is where to construct. We allotted a memory where we can construct the product object. Okay, we decided we are going to build a product object in this location, ABC123. Okay, once you decide where you want to create, then you decide what goes inside. How do I construct this object? Just this is like an empty lot. Okay, in a street, this is an empty lot. There is nothing. This lot contains nothing. It's an empty lot. To fill this, to build the house, you need the blueprint of which class?
Products.
Of product. You go to product class and you check for more details. What does product consist of? What information am I storing in product? I'm storing a variable called a, whose value is 20. So using that information, I will complete building our product object. Okay, that's what we did in this line. So the next line, when you say pp.a, what did it print?
20.
20. Okay, pp, this is the key. Go to that house and get me the value of a. It gave you 20. The first time it printed 20. Let's see what went on here now. Now, we call the add to cart method, the another program, add to cart, we are calling this method. Now we are passing pp, the variable pp, the reference variable pp, to add to cart method. Okay, we are passing that variable, transfer it all the way to the add to cart method. This is where you need to pay attention now. The value of pp is what? What is the value of pp variable?
Right now it's 20.
Wrong.
It's
Uh,
Address.
It's the
ABC123.
reference ABC123.
Okay, so this is what everyone says the first time. The value of product is 20. The value of the value of student is John. Is it really 20, or is it pointing to an address in the memory?
Pointing to an address.
address in the memory.
So what is the value of pp?
ABC123.
ABC123. So when you pass pp variable to add to cart method, this value ABC123 goes all the way to the add to cart method. So now here we have the parameter name declared as p. So what's the value of product p now?
Address
The reference of
ABC123.
same ABC123.
Yes. Okay, the variable p in the other class will have the value ABC123. Okay, because when you say, remember this thing, this is a popular interview question as well. Java is passed by value or passed by reference. They keep asking this question in most of the interviews. Java is passed by value or passed by reference. Okay, passed by value is the right answer. Okay, so when they say pass by, what are they talking about? When you hear the term pass, what are they referring to?
Parameters.
Parameters. Okay, method calls. That's what they are referring to. Okay, so we have a method add to cart, and we are calling that method from this main program. Okay, so here when you write pp, basically you have to use this term, so you get used to this. We are passing pp variable to the add to cart method. That's how you have to phrase it. Okay, on line number 4 we are calling add to cart method and passing pp variable. That's how you need to phrase it. Calling add to cart method and passing pp variable. So anytime they say pass and all that, they're talking about method call. Okay, so when you say pp variable, now what Java does is pass by value, okay, which is typically considered as a whole number, 50 and all that. But when it comes to object, the value you store is what? Is it a literal value or is it a reference?
Reference.
Reference. Okay, so this is the value and these are the variables. For object, the value is reference. And for primitive data type, the value is literal values. Okay, so the right answer to this question, this is a tricky question, Java is pass by value all the time. Okay, but for object, it behaves as pass by reference. That's the right answer. Java is always pass by value. Okay, Java is always pass by value, but for object, it behaves as pass by reference. Okay, they try to trick you. Okay, because when they say value, for object, the value itself is what?
Reference.
Is reference. So that's why they try to trick you by naming this value. Okay, even though we consider hashtag ABC123 as the value for PP, but in reality, what is hashtag ABC123?
Referring to a memory.
It's a reference. It's a reference in the memory. Okay, so it's a tricky question. They try to play with the words. Okay, so the simple answer is for primitive variable, it is passed by value, and for object, it behaves as pass by reference. It behaves as pass by reference. All right. Now, when you say PP, when you pass PP variable to add to cart method, are you really passing the PP or the value of PP?
Value of PP.
Values of PP.
Okay, remember, Java is passed by value. Always remember, Java is passed by value. So when I say s.add to cart and I pass this variable, you're not passing this exact PP variable, but you're passing the reference, the value of PP variable, which in our example is hashtag ABC123. So you're not passing PP to the add to cart method, but you're passing the value hashtag ABC123 to the other method. Okay, so when you pass this value to the other method, the product P receives the value hashtag ABC123. Okay, that's what is happening here. So you guys follow what happens when you make the method call?
Yes.
Okay, it will pass whatever value you have. Okay, you might write PP here, but it is not passing the literal value PP. It is actually passing whatever value you have here, hashtag ABC123. Okay, it gets assigned to the new variable P. When you enter this method, right hand side, what do you have?
Literal value.
The literal value 30. Left hand side, what do you have?
We are accessing A from the product.
Right. So when you say P dot A, what is P pointing to?
Product.
Value A.
Like ABC123.
ABC123. So go to this address, and for the A variable, you're going to assign which value?
30, the literal value.
30. So what will happen here?
It's gonna change.
Is that
Change to 30.
30. Okay. Now this method is done, and you go back to the main program. Now you print sysout pp.a. pp is still pointing to
Same
ABC.
reference.
Okay. You go to this location, and now surprise. When you print pp.a, what is it going to print?
It's changing.
30.
30.
30.
Remember, it's going to print 30 this time.
Yes.
So you guys follow what happens here? Why it printed 20 and then 30? Because they both share the same key to the same house. If two people have the keys to the same house, they both can alter it anyway. Okay, they both can make changes to that house anyway, because they both have the keys. They both can enter and exit that house anytime. That's what happens when you are dealing with objects. For primitive variable, this slightly varies. Okay, so int I equals 50. We declared I equals 50. Remember, this is not a reference, correct? It's not a reference, it's a literal value. Okay, you print this out I, and what do you do? What does it print?
50.
50.
It's 50. Okay, now here when I say s.abc, I'm calling this method abc. Okay, I'm passing I. So when I pass I to the abc method, am I passing value I or the value 50?
50.
You're passing 50. Remember, it is passed by value. When you write it I, you're not passing this variable, but you're passing the value that I contains. In this case, it is 50. So when the 50 value travels all the way to this method ABC, what will be the value for X variable?
50.
50.
Okay, X value will be 50. Now that you come here, you enter this method and you change the value. You assign a new value to X, 30. So here, X value will be changed to 30. Okay. Now you go back to this method, and this time you print the I variable value after you come back from ABC. What will it print?
50.
50, because I value was never changed.
Yes.
What you changed was the X value here. Okay, the whole difference, the whole the main reason it made a big difference is this address sharing, key sharing. Okay, in this case, since you share the same location, any person can make changes to this locker or this house, provided they have the key to that house. In case of this, it will just make a duplicate copy. Okay, in case of primitive variable, you're not really sending the location of I, but you make a duplicate value of 50/50 and you send it. So to put it nicely, when you pass objects, you are literally sharing the key. You made a duplicate key to your house and you shared it. Okay, in case of this primitive variable, you're just making a copy of that, not the exact variable, but the copy of your value. Okay, so now there are two variables which has the 50 value, X and I. So this is like a personal copy. You can make any changes you want. It doesn't impact the original. Okay, in case of objects, the original copy will impact. In case of primitive, the original copy will not impact. It's as simple as that. In case of object, the original copy will change. In case of primitive, the original copy will not change. Okay. All right, so there are 4 programs here. Okay, product. Okay, before I do that, you need to remember how methods are processed. Okay, every time you call the method add to cart, the control goes to the other method. Okay, let me give you a small example. All right, so you're in this program. Everything starts from which program? The application starts from which program?
The void main.
The one which has public static void main. It starts from here. Now it will process this line first. Okay, you begin execution from the very first line in the main method. Okay, it will process this line. It will create a shopping object in the memory and all that, you know, where to construct, how to construct, all that. It will construct the product object later, and then it will print sys out. Okay, after that I'm calling the add to cart method, and finally in the main program I'm printing 2. Okay, now tell me one thing. In this line, if I want to call place order method, how do I do it?
Let's create a reference for checkout, class checkout.
Mhm. And
Now we call for the method.
CO dot place order.
and what do I pass here?
Value.
No. P product.
P dot A.
No.
Second. Please.
What does the, again guys, it is no different than what you guys have been doing so far. What is the input required by place order?
PP.
What is the parameter for place order?
Reference type.
What reference type?
Product.
Product.
P.
So what are you supposed to pass here?
Product.
Do you have any variables that is of type product in this program?
P.
Product P. Here, right there.
Do I write P or P dot A?
P.
Why not P dot A?
Because that's an integer.
P dot A is actually integer. So if you write P dot A, you're passing the A variable from product, which happens to be integer.
Honey.
Okay, you're passing
yeah.
integer, and the place order requires
Reference.
product. Okay, so it is not P dot A, but it is P.
Oh.
Yeah.
All right, so from customer program, we jump to add to cart, and from there we go to checkout. Okay, so we are going to navigate from one program to another program to another program. Okay, that's what we are going to do. What I want you to guess is what will it print in what order. Okay, I'm printing sysout in all the places, in the place order method, in the add to cart method, in the main method. So tell me the sequence on how it will print. Will it print 1, 2, 3, 4, 5, 6?
No.
So what will it print?
1, 3, 5, 6, 4, and 2.
Does anyone have a question on why it will print like that? Do you guys understand why it will print in this odd sequence?
Yes.
No,
Does everyone know that?
I couldn't be able to figure out.
Okay. So you start from the very first line in the main method. You create an object for shopping. Then you create an object for product. Okay. Now this is what we call sequential programming. Sequential. Okay, it goes one line after the next, after the next. Okay, it goes one line after the next and the next. So when you're done with these two lines, what is the next line?
1.
Printing 1. Okay, so it will print 1, the very first number. The next line is add to cart. When you see a method call, the control goes to this method, add to cart. So when you come to this line, you don't proceed with the next line. You have to complete whatever is happening in this method, don't you? When you are on a
Yes.
call with someone, at the same time, can you place another call?
No.
You can't. You have to complete this call. You have to disconnect from that call, and then you can proceed with whatever you're doing. The same concept is here also. When you encounter another method call, the control jumps from here to here. Do you follow what happens in this line?
Yeah.
Okay. You jump from this program into another program. When you come into this method, the same thing again continues, just like main method. In the main method, we began processing one line after the next, right? The same thing happens here. This is also a method, public void, whatever, and then parenthesis. Is this any different? Public void main parenthesis. Isn't this also a method only?
Mm-hmm.
So the same thing happens here. So when you come from line 1, 2, 3, it will print 1. When you encounter another method call, it will pause at this line in this program. It will not continue with the next line. It will pause here and jump to this method. So when you enter this method, what is the first line you see?
Print.
Printing 3.
Mm-hmm.
The very first line in this method is printing 3. So the order is it will print 1. The next thing, it will not print 2, but when you went to add to cart, it printed
3.
3. Okay. Now you reassign a new value 30. You create a checkout object. and you call the method place order, will it print 4?
No,
Jump to the place order.
it's gonna
The
stop and go 5, 6.
Exactly. The control jumps to place order. So here, the first line it prints is 5.
Right.
So now we are in the sequence 1, 3, 5. You have a tax variable. You add that variable to the value 30, assign it here, and what will it print here?
6.
6. So what we have is 1, 3, 5, 6. Now after this line, do we have any more lines to process?
No.
No. When you reach the end of the line in a method, okay, when you reach the end of the line in a method, you go back to whoever called you. So who called place order method?
Good.
Who did?
The main
No,
class.
the shopping method. The shopping
shopping
method.
method and line number
4.
7.
Sorry, 9.
8. Okay, this is where
8.
the method was called. So this is the person who called place order. So basically what happens is when you reach the end of the method, you go back to whoever called you. In this case, line number 8. So when you return from this method, now you continue with the next line, which is printing 4. So it did print 1, 3, 5, 6, and then 4. Okay. Now when you reach the end of this method, where do you go?
Back to the
Go
customer method.
to add two cards.
Tell me exact line number in the class.
7.
7.
7.
Customer class, line 7. Goes to customer class, line 7. So when you return back from this method, now you can continue with the next line, which is
2.
it prints 1, 3, 5, 6, 4, 2. Okay. So do you guys understand how the method call process?
Yes.
How the control goes from one program to another? Now it's the same process, right? Now, usually when you want to apply for a home loan or something, right? You have different people you need to consult. Okay, you have to talk to your some loan approver guy, right? So you fill up the form for your application. Like imagine if you're applying for some universities, you fill up the form and submit it to the approver or whatever you call it, recruiter. Okay. Now, as soon as you submit the form, do you immediately start attending classes?
No.
You wait until your application is processed, right? So when it is processed and you get back a confirmation, only then you can proceed the next step, which is attending classes. It's the same thing here. If you are waiting on someone to respond, in this case, add to cart, you just wait there. You cannot proceed. You wait until this guy has processed your application. So our application here, our request was to add to cart. So we have to wait until that person completes the application, processes the application. The same rule applies here as well, the program. Okay. All right. So you know how the process, how the flow goes. Remember, when you're passing object to another method, what will happen? When you pass objects, in this case product, what do you have to remember? Object versus primitive.
As reference value.
It sends the reference value. And what is the outcome of that? What is the outcome? any changes you do in the other program
will be reflected
will
in
be
the
reflected everywhere who has access to that variable. It will be reflected everywhere. Remember that. That's the key difference. When you pass objects to another method, any changes that you do here or here, it will be reflected all over the places, unlike primitive data type. Okay. All right. So let's start. Okay. So Shrestha, what will it print here?
sir. pp dot a it will print 20.
20. Yes. So Bhakta, what happens next after it prints 20?
After it prints 20, it will call for method add to cart. So here it will call for the product pp, the same reference class. Then it will print, it will replace the value of the original value to new value.
Okay, wait. One step at a time.
Okay,
From this
then
line, where do you go next?
it will go to add to cart, like shopping class.
Okay.
Because it is calling, because it's calling for the method add to cart. And there in add to cart, it will take, it will go to product P, and it will take the value A, which was 20. But this time,
that's it. Just hold on. That's it. So the next step is it will go to add to cart method and it will print 20.
Yeah.
That's all. Okay. So Ashmita, what happens next?
So next it will print the value, the new value, which is 30.
30. So when you make changes 30 here on the P variable, will that reflect to the PP variable as well?
Yes, because it's a reference variable.
Exactly. The name does not matter. They all are pointing to the same reference. Okay, so when you make changes here, it's actually happening, impacting this as well, PP as well. All right. So Manish, what happens next?
Then we call another class checkout. So then we place so we did a reference. So for the checkout class over here, we call a method to place an order with the value key. So that moved to the other class checkout.
Okay, you came here.
Yes.
So
then,
Rohit, what will it print here? 20 or 30?
I believe it will take 30 plus tax, the value.
Yes. So when you're dealing with reference, the same object, all throughout the program, you will notice I did call new product only once, didn't I? You're using, see, this is what you guys need to focus on. I have a product variable here that I pass to here, and then I pass to here. So all throughout our application, we have 3 product variables. Okay, you can call this anything. You can call this P1, doesn't matter. Okay, you can call this P1. Name doesn't matter, it is just an alias. Okay, so focus on these three variables in your project. You have product PP, product P, product P1. Three variables. Okay, we are circulating the same copy everywhere, right? We created only one copy, isn't it? When you say new product, there is only one copy in the entire memory for this PP variable. Only one copy. Remember, there's only one copy. Now, the same PP variable we circulate to add to cart method. When it comes here, this variable, the same variable which was initially created here, is now passed to place order. Okay, the same variable is now passed to place order. So throughout the program, how many product objects do we have?
Only one.
Only one. How many variables did we have?
Hmm.
Three.
Three. We have PP, variable PP, reference variable PP. We have parameter variable product P. We have parameter product variable P1. We have three variables, but among these three, don't we have the same copy?
We have one.
One.
Yes.
One
One
object.
key.
So anytime any one of this person makes changes, won't it reflect in the same copy that you have here?
Yes.
Okay, remember that. Now, so when you do changes to the P variable, the original copy also gets impacted. Okay, now we pass that variable to checkout, and the checkout person again makes changes to the A variable. It will add tax on top of this value 30. Okay, so what will it print here now?
35.
35. 30 plus the value of tax, which is
35.
So 30 plus 5, 35. It will print 35. So we had 20, then we had another 20, then we had 30. Okay, 20, 20, 30, followed by
35.
35. Okay, when you reach the end of the method, where will it go?
Back to the
Go back
Line number.
to second. It's order.
So what will it print here? 20, 30, or 35?
35.
35.
35. Because the same copy was updated in this program to 35. So we have 20, 20, 30, 35, 35. Okay, 20, 20, 30, 35, 35. Now, when I come back here, it prints 35, right? What happens after this line?
Go back to the customer class.
Go back to the customer program.
Line
And
7.
when you come back from add to cart, what will it print?
35.
35.
So our guess is 20, 20, 30,
35,
3
30.
times 20, 30, 35, 35, 35. You can follow how the program worked and how the values were changing. Okay, so think about this like an application form. Okay, so you go to a bank, the same example, loan application bank. Now the first thing you do is you go to the reception counter and what do you ask them? You ask them, I need a form to apply for a loan. don't you? Okay, it doesn't apply to bank. It can be anything, DMV, university, anything. Okay, so even in DMV, as soon as you go to the reception, don't you select the form? Which form? Don't you fill up the form for a new driver license, for a stolen driver license, and so on?
Mm-hmm.
Now, when you fill up the form, that's what we are doing here. We created a new form, product, and we filled our information, 20. Don't you take the same form to the counter? Or when you reach the counter, where they take your picture, take your fingerprint, do you fill another form there?
No, same form.
You take the same form. And what does that person do when you're going through all the tests? You know, doing your eye checkup, your fingerprint, and all that. What do they do in that form?
They update.
They update it, right? They add more information. Eye check, pass. Fingerprint, done. Don't they add all that information in the same form that you initially filled up?
Yes.
Mm-hmm.
Now, once you go through that test, eye checkup and your fingerprint and all, next you go for the driving test. Now, don't you carry the same form where the, what do you call them? Instructor or whatever, who take your exam,
The police officer.
right? Now, when you are done with your driving test, doesn't that person update the same form that you passed the test or you failed it,
The same.
right? So you fill up the form at the reception, you go to the counter and you give your test. Okay, you give your eye checkup and your fingerprint and all that. Then you go for your actual driving test where the final remarks will be written. You cleared the test, you failed the test, you had these many errors when you were driving. All the while, they are updating that information on the same form, isn't it? Right? So in this case, do you guys understand what comparison I'm doing? Yes or no?
Yes.
So if that application driving form was your, that form was your application for driving, what is the form in this project? What is the application form that is exchanging hand from person to person in this project?
Product.
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 The product class is your form, which is being exchanged from person to person to person. Okay, everyone is receiving the same form. This is your form, which keeps getting updated over and over. You fill up initially with the default value 20. That form is sent to add to cart, who updates with some more information. The same form is now sent to checkout, who is updating in additional information. In the end, the final copy you have when you walk out of the DMV is the one form which was written, which was updated by every person here. Reception, the counter, and the driving test, everything. That's the same comparison to this example as well. Okay, you pass objects in order to retain information. Why do we pass objects? The same object to other program? What happens? Yeah, let me give an example and maybe you might understand. What will it print now? Simple question. How many application forms do you have here?
Only one product.
How many forms did you create?
4.
Reference.
How many forms, product forms you created?
2.
2.
One was here, another was here. Okay, place order requires product. I'm passing P11. Is P11 a product as well?
Yes.
So it is perfectly fine. I can pass P11 or I can pass P. I can pass either one of the variables because they both are product. Both are fine. If I do a slight change and make it 11, the output will be entirely different. Again, what will it print here? You created a brand new product. You created a brand new product form. What will it print here?
20.
20. Okay. You pass the same product form to add to cart here. The very first line, what will it print?
20.
20.
20. You updated that form to 30 now. Okay, you change the value from 20 to 30. Here, when you do checkout, when you create checkout object, you created another brand new object. Remember, another brand new object. Is it the same object as this one?
No.
No, it's a
No.
brand new object. So when you pass that object, the brand new object, when you pass it, what will it print here?
20.
To print 20. It didn't print 30 like last time because the same copy was not circulated. We did not circulate the same copy to the next program. We created a brand new program, brand new form here. So when you create a brand new form, the default value you get when you create the new form is 20. So when you pass P11, the first line it did was it print 20. So what will it print here?
35.
35. Okay, 30 plus 5, 35. But this place it will print 20.
Okay.
Okay. Now you did 35 and all that. When you come back, what will it print here?
20.
35.
30.
20, 35, 30. Which one?
35.
35.
35.
Pay attention. When you send this object, it got updated to 35, isn't it?
Yes.
In this program, it got updated to 35. When you send P11, P11 is the one which got updated to 35. What am I printing here?
E dot A.
I'm printing P.A. Am I printing P11.A?
No.
No.
20.
So before you created this object, what was the value for P.A?
30.
30.
And that's why it will print 30. You come back,
Whoa.
and what will it print here?
30.
30.
30.
Okay, so the answer is 20, 20, 20.
35.
It's 20 because we created brand new object. It will not be 30. Okay, so we have 20, 20, 20, 35, 30, and 30. Okay, so as compared to the last output, it will be totally different. It will be 20, 20, 20, followed by 35, followed by 30 and 30. That's what you get. 20, 20, 20, 35, and 30, 30. Okay. Let's look at this program from this chart. It would make more sense when you have visualization. Okay. Since I don't have much space, I'll just write the method names. So it's easier to fit in the screen. Okay, this is not easy to get. So as a beginners, you guys have to make a practice of using charts. Okay, this is the best way you guys can actually understand that. As a beginner, I would encourage you to do this thing. Okay, this is the main program, followed by the shopping program, followed by the checkout program. Okay, we have 3 programs. Okay, we'll just focus on the methods that we are dealing with. All right. So product P equals new product. What happens in the memory?
Reference is created for the object product.
And
Location allocated for the variables.
so where to build your object? What's next?
Blueprint.
Address.
Blueprint of product. So what does product has?
Int A equals 20.
Variables.
We have A20. All right. So now that we created where and how is done, what comes next?
Assign it to variable PP.
Yes. Okay, so we are done with line number 1. You say pp.a. What will it print?
20.
20.
Sure.
You call the add to cart method and you pass pp. Pass. When you say you pass pp, what exactly are you passing to add to cart method?
Value reference value.
The reference
Values.
value 111. Very good. Okay. So you're not passing pp, but you're passing the value of this p variable. Okay, that is 111. So when you send or pass hashtag 111, it travels all the way to add to cart method. And here the parameter name is p. Okay, the parameter name is p. So what is the value of p now?
111.
111. Okay, so far everyone is with me. Add to cart, the very first line you say p.a. What will it print?
20. I got
20.
20.
Pointing to 111, go to that address, get the a value. Yes, it will print 20. You're changing the value of 30, p.a to 30. Will it reflect to pp variable as well?
Yes.
Yes. Okay, when you say P dot A, if PP wants to check what is the value of product, what will it see? 20 or 30?
30.
30. So whatever changes you did in this line, it also impacts the main program. Okay, all right. So it prints 20. Okay, let's make a note. The first line here, it printed 20. We go to add to cart method here, and we enter here. It again printed 20. Okay, that is our output, 20 and 20. Now, I create checkout object in order to call place order, right? I create product P11 equals new product. What will happen in the memory? Product P11 equals new product.
It will create a brand new.
You create a brand new object. New meaning brand new object. The same process continues. Creating a product, finding the right location. You cannot create this object in the same place. Remember, if two people are buying home, they don't construct their home in the same address, don't they? They'll have their own addresses, isn't it? Yes or no?
Yes.
So if you call new product twice in your project, isn't it going to create two different locations?
Yes.
Okay. All right. So default value of A is 20. We'll keep that when you create a brand new object. Now, when you say co.place order, when you call place order and you send P11, okay, let me complete this. P11 has what?
Has 222.
222.
222.
All right. So when you say co.place order and you pass P11, what does the place order P1 receive?
Value.
Value.
222. It's not 111 because we are passing P11.
No, it's 222.
P11 is 222. So what you get is the value of P11, which is 222. So what is the value of P1 here?
222.
222.
222.
Okay. You enter and you say P1.A. When you say P1.A, what will it print?
20.
20.
20.
Okay. Next, tax variable 5, add 30 plus 5, 35. You assign it to P1.A. What happens in this line? Where do I update 35? In 111 or 222?
222.
When you say P1.A, P1 is the second object. Here, we are going to update 30 plus 5, 35. All right. So when you say sys out P1.A, what will it print?
35.
35.
When you're done with this method, where do you go?
Back to line number
Line number 11.
7.
So on line number 12, the next line, after you return from place order, it says P.A. So what is P.A?
30.
30.
When you're done with the last line here, where do you go?
Line number 3.
What will it print? P.A.
30.
30. Because PP. Oh, okay.
Triple 20, 35, 30, 30. That's the reason. All right, so Adil, what happens here? Karim, Ahmed, Anusha.
Allocate address in the memory for product.
And what
And
happens?
refer the class to build the object. So A20.
All right.
And assign it to a variable PP 111.
Let's call the main point. All right, so Ashmita,
Yes.
explain these two lines.
Okay, so after that, it's gonna print out the main prod dot a, which would be the it's passing the value, which is 20. Getting
Okay.
the value 20.
So first it will print 20. What
Yes.
happens on this line?
Now calling them. It's gonna go to the method add to cart. That's line number 6,
Mhm.
and it's gonna the reference value is p over there. So the new the value would be the same of address 111.
Very good. Bhakta,
Yes, sir.
line 7 and 8.
Yeah, 7 and 8. Now it goes like uh, in number 7, P, since reference, it has the reference 111, it will take the value from the reference 111, and it will print the same value 20.
Okay, it will print 20.
Yeah, because it is going to same reference 111.
Mhm. What happens here?
Okay, over there now we have assigned new value to A 30, so it will replace value 20 by 30 in the same reference, because it has the key for the same reference, so it will replace the value by 30 this time.
Good. Now the next line is going to create a checkout object, because if you want to call place order, we need to create an object of checkout. So Rohil, explain line 10.
Line 10 is just like the procedure 1 to like what happened on 1. There will be a new place created, then there will be Bluetooth assigned, and then we'll pass the reference variable.
What will be the value for A?
It will be
And the
P11.
object.
It will be 20.
Okay, I created the object. We have an address. What next?
The blueprint. It has blueprint, and then it will code for the reference.
Okay.
Like P11 and 222.
All right. Vardha,
Yes.
line 11.
It's taking the same value for P11 to 20.
Now we are on this line. What happens next?
Okay, we're going to the place order.
Yes.
Right here. Mm-hmm.
And what do we do here?
We have P1 dot A, which has the same, what's the value, 5, so it's gonna be,
See, you have to put everything on the map here. If you need a good visualization, don't miss anything. You have to account for all the variables. You have to account for all the changes that happens in the object. You have to account for what is the output. So, in this line, what happens?
it's gonna print the value, the same 222.
Value 222. Is it going to print 222?
No, it's gonna print 20.
P1 gets 2222.
Yeah, P1 gets the address area 222.
You have to account for that.
Oh,
If you
yes.
don't write it here, how will you keep track of that? If you
So
don't mention P1, the next time when you make changes to P1, you can't account for that. You have to put everything on the map. So P1 has the value of what?
Hashtag 222. Yes, which is printing 20.
Now tell me what will it do in line number 16?
It's gonna print 20 because P1 has 222 and which is assigning a value which is 20, so it's gonna print 20.
Salikram, explain these 3 lines.
Thank you, but I knew.
We have initialized the text equals to 5.
Put it on the map. You have a tax variable whose value is 5. Okay, next.
And then we already had objects, no parameters P1.
Remember the rule. If you have equal sign, what does it mean?
Create an in your product.
Value to P1.
Equal sign means right hand side first.
Yes, sir.
What do you have on the right hand side?
It's create a new product.
So emphasize on that. What does new product means?
Create a new object.
Create a new object. New means new object every single time. So what will be the process? How the new product object is created?
Maybe product. It's gonna get new reference value for this object. And this is gonna initialize to like P1 222 to 333. It's gonna change.
You are right. It will update to 333, but what is the content of this?
Oh, product. Product. It's gonna access the like member variable of product class A equals to 20.
Okay, very good. So you have PA20. Now this is what happens. On the right hand side, whatever new object you created, that address gets imprinted on P1. So P1 will lose its touch from 222 and it will have the value 333. That's what happened in this line.
Yes, sir.
Okay, very good. All right, Sabuj.
Yes, sir.
Line 19 and 20.
Now the new value 30 plus text. The 35 will be assigned to the address 222.
Look at the graph. The visualization will help.
Yeah, the new value 35 assigned to address 333.
Yes. P1.A.
P1
is address 333.
Yeah.
So this A value will change to?
Will change to 35.
Yes. When you say sysout P1.A, it will print what?
It will print 35.
Set?
35.
Yes. Okay, Rajan, what happens after this line?
I think we don't after that.
What happens when you reach the end of the line in a method?
We go back to the line 11, 12, and then we execute 12.
You go back to whoever called place order, which is?
Sorry. 11, and then we go execute 11, 12.
So the next line, P.A.
So it should be P.A.
Should be 30.
35.
We print 30.
It's 30.
What happens after this line?
It goes back to
the number
3.
What will it print now?
30.
30.
So this is the output. If you want, you can just copy paste all the lines in all the programs. Twenty, 20, 35, 30, 30. Okay, this might look scary, but if you just, in the beginning, you guys have to do this slow process to understand the program. Okay, but eventually I'll tell you, this map will just auto-generate in your mind. Okay, you'll start tracking all the things without even knowing. Okay, but until then, until you guys get a hold of this whole thing, you might have to do this visualization until you perfect it. Okay, you all guess the right output. Even though you might seem at a first glance, it might look like chaos. What's happening? So many methods, so many variables. We are printing here, printing there. It might look chaos. Just sit back, relax, go line by line. Everything will fall in its own place. Track the program, list the variables, put references, whatever changes happen, update them, and guess the output. Okay, and then we'll stop this session.
This conference will now be recorded.
Okay, it's as simple as throughout your project, if there's only one product object which is exchanging the same reference everywhere, then your program is pretty straightforward. Okay, you won't have to worry about it. You can just keep tracking what updates are being done. Okay, but when your project has multiple product objects being created here, and then another new product, that's when you run into problems. Okay, that's when you have to be careful and see what product are we updating. Are we producting the original object, or did we create a new product and made changes there? Okay, that's the only trick here. As long as if you have only one product object to track throughout the project, then it becomes easier. So any other guesses? Rupesh?
Yes.
Do you have any answers?
Here's 20, 20, 30, 20, 20, 30.
30?
1 second. 30.
Rohil?
Yes, sir.
Any guess?
No, I don't have guesses, but yeah. Where do we have 20 in the program? I don't see any 20 in the program.
Okay, again, when you say product, I can't fit in all the programs.
Sorry.
I can't fit in all the programs in this spreadsheet. So I'm just using chunks of code here and there. You need to know when you create a product object, the default value is 20 anyway, isn't it?
Done.
When you create a product object, when you create a brand new product object, the default value is 20, isn't it?
Yes, sir. So let's do it. Okay, the first sys out will give you 20. Then we do the method s.add to cart. Then we go to add to cart. So the value is still 20. Then, then we give the new p equal to new product. So then we assigned the value 30. Then we went to checkout. So checkout is then here it will come 30, like under. Then after that again we went back to the program. System dot hold on, I'm lost over here. Yeah, then it will go to 30. Then we're gonna add 5 in it, so it will print 35, and then it's gonna go back to the main method, and it's gonna print 35.
All right, so product, main product. Okay, let me cut it short. New product, we create a new product object. Product object, look at the blueprint. It's not on the spreadsheet. The blueprint is here, which is A equals 20. So when you create a new product, the default value you get is 20. That's line number 1. You print it, of course, it's 20. The first number is 20. Pass main product to add to cart. So parameter P will have what value?
111.
Next, you say P dot A. P is pointing to 111. A is 20. What happens on this line?
Create a new product.
Creating a new product.
A brand new product with default value 20 in a different location. After that, what happens?
So change the value of P dot A to 30.
You have to replace the reference, isn't it?
Yes.
It will point to new object. P equals new product now, meaning P is pointing to a new product object. That's what it says clearly. P is now pointing to new product. So you have to point to the new product. When you say P dot A equals 30, which object did it change?
222.
222.
Create checkout object and call the place order method. So when you pass P, what happens? What are you really passing here?
30.
A value 30.
Are you passing value 30?
222.
Sorry, 222.
No, you're passing 222.
2. So what happens in this line?
It will print value for P.
The line that I highlighted. Are we doing printing here?
No, we are
No, that's a method.
So what happens in that line?
we're passing the value.
You're passing the value 222. When you pass the value 222 to this line, what happens?
P1 equals
P1 will get
P1 equals
222.
See, when you're dealing with a complex program in your projects, there will be hundreds of classes. If you lose track of even one variable, you won't be able to understand what's going on. You have to track everything. P1.A, what will it print?
30.
Next equals 5. P1 equals new product.
Create a new product again.
3.
What is the content?
A 20.
20.
Default value 20.
What happens next?
P1 is assigned 333.
Very good. Now 30 plus 5, 35 goes to which one? 1, 2, 3.
333.
333.
Print P1 dot A.
35 will be
35.
35.
Where do you go back from here?
Line number 12.
What is P dot A?
20.
30.
30.
Sorry, 30. Yeah.
Where do you go from here?
Line
Line
number
4.
Line number 4.
What is main prod dot A?
20.
20.
20.
Twenty, 20, 30, 35, 30, 20. 20, 30, 35, 30, 20. I'll send you guys these 4 programs. Okay, look out for this. And I would say copy this program in your Eclipse, Spring Tool Suite, whatever, and make changes. Okay, move this line 1 below, or maybe here. Okay, move this new product somewhere. Change the value, 30, 15, whatever, and guess the output. Guess the output, write down in a piece of paper what will it print, and then go to the customer class, right click, run as entirely different output, and see if your guess was right. If you analyze, the right word is not guess, guess meaning you didn't do your homework. This is analyzing the program. Okay, if you want to see what's the problem in your program, you need to be able to do this. Okay, if someone says your website is not working, I can't pay my bills, what do you do then? You should be able to understand what this lines means. What do they do? If you do not understand what this is doing, you won't be able to figure out what's the problem. So this is what we call analyzing. You should be able to perform this task. Okay, it's an everyday thing we do. Writing program is one thing. Like I said, if you guys join any company, that website will be around for more than a decade, obviously. Bank of America, American Airlines, whichever company you join, those websites are around for decades. So most likely you will run into a project which already has programs. And when you are asked to fix a problem, I cannot log in, I cannot pay my bill, I can't see my profile. If someone complains, you should be able to look at this code and tell what the problem is. You can do that if you have this kind of a skill. If you know how to spot problems, if you can track your program without running it. So you understand what's the importance of this, right?